right, good morning. My name is Sandeep. Today, I want to talk to you about microservices with Kubernetes and Istio. So I'm a developer advocate on the Google Cloud. I've been working with Kubernetes for the past 3 years. It's grown a lot. And Istio is the next new hot thing coming out, so you're all here to learn about it. So let's go. Because we all know microservices are awesome, right? When you have a traditional application, like a monolith, you'd have all of your logic in one app, right? So a Java app, Ruby app, Node, whatever. You would have all the code in your one app. It would do all the parts. Maybe you're using like object orientation, so you have different classes that do different things. But at the end of the day, it's like one big program that does all the stuff. And there's a lot of advantages to doing this monolithic type of development. It's easier to debug. It's easier to deploy. You just have one thing. You just push it out, and you're done. And when you have a really small team and you have a really small app, it's really easy to do. But the problem with the monolith comes when your app starts to grow a little bigger. So now you have all of these things and all these different pieces, but you still have one app that's doing all of it, right? So anytime you want to make a change in invoicing, that means you had to redeploy the whole thing, even though the ETL pipeline might have not been affected at all. And maybe the invoicing part is really good to be done in Java. The ETL pipeline, you want to use Python. And in the front end, you want to use Node.js. But if you have a monolithic app, you can't really do that. You're kind of stuck into using one language. So a team that wants to make an update to one little part has to touch the whole thing. And things start to get really hairy really quickly. So with microservices, each one of these becomes its own individual component that can be written in its own language, that can be updated and deployed independently of the others. And so this gives you a lot more agility, a lot more flexibility, a lot more speed, and a lot more cool things like that. And so you're like, yeah, that sounds really good. Why is anyone using monoliths? Because once you start growing even bigger, it gets even more complicated, right? Honestly, a monolith would fall apart at this point too, but even all the advantages of the microservice start to get really hard to manage. Because now you don't have just 20 microservices, you have 2,000 microservices, right? And how do you know which one talks to which one and how the intricate spider web of connections even works? You might have a single request that comes into your load balancer that gets sent to like 20,000 different microservices and then all the way back up, and anywhere that chain breaks, your whole application looks like it's broken, right? And so debugging this becomes super hard. Deploying things, making sure everything's in lockstep with each other, it becomes really difficult to try to manage this huge stack of services. So are microservices terrible? Maybe. But we can use a lot of tooling to try to make them more manageable, right? So let's use tools to kind of automate this infrastructure components, automate the networking components, automate the management side of things. And so when you look at a monolith versus a microservice, they both have a lot of complexity. The difference is, unless you know something that I don't, there's no tools out there that automatically write code for you and can maintain a 2 million line Java app, right? There's like some magic AI that can write code, but it'll all be out of jobs, maybe in a few years. But now we do have tools like Kubernetes, like Docker, like Istio, like Google Cloud, that can automate infrastructure a lot more easily, right? So a lot of the issues that we have with microservices can be automated away. So let's take a look at some of those tools. So how many people are familiar with Docker? I expect a lot of hands to go up. Yep. So for those of you who are not familiar with Docker, Docker is basically a way to package your application. So it doesn't matter if you're writing Node code, Python, Java, whatever. It doesn't matter if you have ImageMagick, some random library that some 13-year-old kid in Ukraine compiled. It doesn't matter. You put it in your Docker container, and you're good to go. All you have to do is care about running the container. You don't have to care about running what's inside of it, right? So basically, you take your code and your dependencies, and you put it into some sort of generic container format. And so it doesn't matter what's inside. As long as you can run a container, you can run all the containers. So now you have a container. You got to actually run it on your cluster, right? Because logging into a single machine and then running Docker run and then doing that 1,000 times seems like a waste of time to me. So instead, we can use something like Kubernetes, which is a container orchestration system. And what we can do with that is we can say, hey, Kubernetes, run this container like 5 times somewhere in my cluster. And so what it'll do is it'll run your containers for you automatically, right? And so let's say you want to run this container, that container, that container, and that container, and you want 2 copies of each. You just tell Kubernetes that, and it figures out how to run them. And so the really nice thing about this is if a server crashes, it'll figure out that that server crashed and run them somewhere else. If an application crashes, it'll figure that out. If you want to scale it up, right, you want to go from 2 copies to 4 copies, you can say, hey, make it 4, and it'll spin up 2 more. You want to go down to 1 because you like, want to save some money, you can say, hey, make 1, it'll remove 3, right? And so this is like a declarative syntax that makes it really easy to manage these containers running on your cluster, right? You might have thousands of these running. Trying to do it manually is going to be impossible. And how many people have heard of Kubernetes? And keep your hands up if you've used it before. About half. OK, cool. But that's kind of just a starting point, right? Now you have these containers running. You have to manage the services. Because you have container A talking to container B, talking to container C, talking to container D. How do you manage that set of points going between each other? How do you set rules on who can talk to who can talk to what? How many tries should you have? How much network traffic should you send? All this kind of stuff becomes really complicated. And that's where Istio comes into play. So Istio is a service mesh, which at the end of the day, it means that it manages your services and the connections that they make between themselves, right? So if you look at it, we take orchestration, and we go to management and communication. So you want to manage how these services interact with each other, because that's what really causes microservices to be so useful, is the communication between each other. You can reuse one service, you can talk to 3 different ones, give it the same information, you can mix and match, you can do all these really powerful things, but it becomes hard to really understand what's happening. And Istio makes it a lot easier to understand what's happening and control what's happening. All right, so that's enough of me just talking about random things. Let's actually move to a demo. And if we can go to the screen, thank you very much. OK, and I can't see anything. Sweet. So what we're going to do first, actually, can we go back to the slides real quick? I'm going to tell you what we're going to do. So what we're going to do is walk through the end-to-end story of taking an app and making it into a microservice. So we're going to take an app, put it into a container, run that container locally, store the container on the cloud, then we're going to create a Kubernetes cluster, run our app on that cluster, then scale it out, and then we're going to do something a little bit more interesting. We're going to run multiple apps that work together, a true microservices pattern, and then we're going to monitor and manage them with Istio. Awesome. So let's move back to the demo. Cool. So here I'm using Google Cloud Shell. If you haven't used it before, it's basically a free VM in the cloud that lets you do your development work. I'm on a Chromebook right now running the dev build. If it all crashes, we're going to do like jumping jacks until it comes back or something. I don't know. It happens before. So basically here, I have some code. It's a little Node.js application. If you don't know JavaScript, that's fine. It's a really simple app. Basically, it's a web server that listens to /, and it will basically ping a downstream. So in this case, it'll ping time.jsontest.com, and then it'll concatenate that response and then send it to us. So let's run this locally right now. Nope. Don't want node modules. OK. Ugh. Internet. OK. So if I go npm start, see what happens. Cool. So it's listening on port 3000. So I will. That's fine, I'll do this. Let's go to port 3000. So on Cloud Shell, we can do a web preview. So it looks like we're basically running a local machine. Awesome. So you can see here that we go to time.jsontest.com, and we print out our current service name, which is test1 version 1, and we're seeing the current time. So if I refresh this, the time will change, right? Awesome, cool. So now let's take this and put it into a Docker container. So to make a Docker container, basically what we do is we make something called a Docker file. And so a Docker file is basically a set of instructions that creates this like endpoint. So you can almost think of it like a bash script. it's basically what it is. So here we start with Node 8 Alpine. So that's kind of a base image. It gives us a bunch of the Node stuff out of the box, so we don't have to worry about installing Node.js. Then we copy in our package.json, which has our dependencies. Run npm install to install those dependencies. Copy in our index.js, which is our code. Expose some ports, and then run npm start. So once we run docker build, it'll create a Docker container. So let's actually build and run that container. Just for the sake of time, I've already built it. So run local. So here, when I run that container, once I built it, OK. Oh, nope, I need to build it. Cool. So let's actually just build it. It's just not found. So this might take a little bit of time. And while we're building this, let's switch to going and building our Kubernetes cluster. So here, in our Kubernetes, if I go to the Google Kubernetes engine, Google Kubernetes engine is Google's managed Kubernetes offering, right? And so it's probably the easiest way to create a production-ready Kubernetes cluster. So what you can do is just click Create Cluster, and you get a bunch of options on what you can do to create this cluster. So here you can give it a name, you can give it a description. You can make it a zonal or a regional cluster, and this is a really cool feature where you can have multiple masters, so it's highly available. So even if a zone goes down, your cluster will still be up and running. You can choose the version of Kubernetes you want, the size of the cluster, and then a bunch of, not -21, let's not do that. You can do a lot of other cool features, too, that Google Kubernetes engine gives you out of the box. Things like automatically upgrading your nodes, automatically repairing them if they get broken, logging, monitoring, and a lot more, too. For example, auto-scaling. You can turn auto-scaling on, which means that if you have more containers that can fit in your cluster, Google Kubernetes engine will actually automatically scale it up to create that space. And even better, if you have less containers, we'll actually scale it down to save you money, which is really cool. So cool, a lot of that cool stuff. And then all you have to do is click Create, and it'll create that cluster. So I'm going to click Cancel because I already did one. It's like a cooking show. We have one ready in the oven. This is still going. That's OK. What we'll do instead, because I've already built this, and I've pushed it, so we're going to do the opposite of what I said, and we're going to pull it down. Sweet. So I kind of cheated, but that's OK. So let's run that container locally. OK. So what we're going to do with Docker is we're going to say Docker run, and then we're going to open up that port 3000. And so if you go back here, you can see that it's basically the exact same thing, except now it's running in Docker. And so the really nice thing is we didn't have to change any of our code. We just put it into a Docker container, and we're good to go, right? OK, cool. So the next step is actually pushing it to a container registry. And the reason why we have to do this is because we can't just run containers running on our local machine. We have to push them to a secure location so we can run them on our cluster. And Google Container Registry is probably the best place to put them if you're running Google Kubernetes engine, right? You get automatic authentication and stuff, and a few other features we'll look at in a second. So let's actually push it up. That's not how you spell make. M-A-K-E. I love using make. It makes demos super easy. So what we're going to do is run docker push. And can people read that, or should I make it a little bigger? All right, people can read it. So docker push, and then give the name of the container. So what will happen is it'll actually go to Google Container Registry. And so here in my Istio test container, you can see that we have the newest one pushed up right now. And it's tagged as version 1.0. Now, if I enabled it, one really cool thing that it could do is vulnerability scanning. So we can actually scan your containers for known vulnerabilities automatically for any Ubuntu or Alpine-based images. So that's a really cool thing, especially if you have older containers that you haven't updated in a while. You go back and look, and you'll have tons of vulnerabilities. So it's a really good idea to check this out. It's in beta right now, but it'll find a bunch of stuff wrong with your things and tell you how to fix them, and then you just go usually just update your containers, and you're good to go. So it's a really good thing, especially running in production and running older containers. So now we have this pushed up, we actually can start to deploy it to our Kubernetes cluster. So like I said before, we already have a cluster created. So let's go back there. Now, basically, to connect to it, we just run this command. All right, let's run it. Great. So now we can say kubectl, which is a Kubernetes command line tool, get nodes, just to make sure everything is working. Is everything working? That's a good question. Yep, there it is. So we have a 4-node Kubernetes cluster. They're all good to go. We're running version 1.9.7. So here, now that we have our Kubernetes cluster and we're authenticated to it, we can start running the same container that we ran locally. So what we're going to do is do kubectl run demo, and then give it the name of that image. And demo is going to be the name of the deployment that we're going to create. So if I say kubectl get deployment, and then give that namespace. The namespace is just for this demo's sake. Don't worry about it. You don't need that in real life. So you can see that we have our demo deployment created. And if you say get pods, and so pods are basically the containers in Kubernetes. You can see that we have our container created, it's ready, and it's running. But now that it's running, you have to be able to actually access it, right? And so this is where it gets a little bit more complicated, where in the old world with Docker, you just kind of access it directly, because this is running on your local machine. But in the Kubernetes world, it's running on one of those 4 nodes, and we really don't care which one. So we want a static endpoint that can route traffic and access that, that node, right? So what we're going to do is create a service. Nope. And now I forget what my make command is. That's OK. I'll just go look. It's like a cheat sheet. Let's see. Expose. There it is. Cool. So what we'll do here is we'll run kubectl expose, and then we'll give it the target port of 3000, which is where our Node.js app is listening, and then run it on port 80, so that's the normal HTTP port. And we'll open a type load balancer, which will give us a public IP address using a Google Cloud load balancer. So now we can say get service. And I assume most people here are familiar with Kubernetes. If you're not familiar, come and just talk to me. I know I'm going kind of quickly, but there's more exciting things to happen soon, so we want to get to them. So you can see the external IP address is pending. So let's just run a watch on that. And it's done the moment I try anything complicated. It just finishes. It knows. All right, cool. Let's go to that URL. That did not copy it. All right. Ugh, all right. All right, all right, all right. We'll just do this. Cool. And if we go here, you can see the exact same app running on our cluster. So now we actually have it running on a public IP address. If you go there on your phone or laptop, it'll work. And what we can do, let's say all you go on your phone to this IP address, will probably overwhelm this app. So in Kubernetes, we can actually just scale it out with the scale command. So let's do that. So let's say kubectl scale deployment demo, the name of the deployment. Then we'll say replicas equals 5. And again, that namespace. Awesome. So it'll say deployment demo scaled. So now if we go back to our get pods, you'll notice that we actually have 5 of them running in our cluster, which is really cool. So, and then if we say get deployments, you can see it also says that we have 5 desired, 5 current, 5 up-to-date, and 5 available. So now if we go back to this IP address, it still works. The only difference is it's now round-robining traffic between all 5 instances of our application, right? So we have a lot more scalability, a lot more robustness. And you might notice that we're running 5 copies even though we only have 4 VMs, right? That's because we're able to run multiple copies on a single VM, so we get more utilization out of our machines. OK. Let's see, clean. All right, so let's clean that up. We no longer need that demo. Let's start looking at Istio. So now we had a single service running, kind of useless in the long scheme of things, right? No one just runs one thing. You don't need Kubernetes to do that. What you really want to do is run multiple applications together and make sure they all work together well. So what we're going to do is, cool. What we're going to do is run this same application 3 times and then chain it together. So you might have noticed in our code, I'm going to go back to it for a second, that basically I can set whatever I want as the upstream URI using an environment variable. And so what I can do is actually tie multiple of these together using one to talk to the other, and then finally to time.jsontest.com. And then they will all concatenate their responses and finally show it to the end user. So that's a really cool thing. And in Kubernetes, we can actually dynamically set these environment variables when we're deploying. So let's actually look at that. And so normally in Kubernetes, what we would do is we would create a YAML file. And I'll make this a little bigger. And in this YAML file, we will define our deployments. So I'm going to make 4 deployments. So the first one's going to become called front-end prod, so front-end production service. As you can see here, I'm giving it the service name front-end prod. And the upstream URI, I'm going to call it middleware. And so Kubernetes will automatically do DNS-based service discovery, so I can actually find my middleware application by just pointing it at middleware. This is really cool. I don't need IP addresses or anything like that. And you can see here we're giving it some labels, app frontend, version prod, and then the same container name that we used before. And then in our middleware, everything looks exactly the same, except it's app middleware version prod, and then the service name is different, and the upstream URI is now backend. Then we also have a canary version of our middleware, so it's like our test version that we're just kind of working on, but we want to see how it works in the real world. So again, this also points to backend, and then finally our backend, which points to time.jsontest.com. OK, so at this point, we can deploy it into our cluster. And so now we'll create these deployments. But of course, we also need to create the corresponding services so they can actually find each other. So let's take a look at that. So here in our services.yaml, it's pretty straightforward. We have a front end, a middleware, and a back end service. They all open up port 3000 to port 80, which makes sense. The only difference here is the front end service is of type load balancer, so that we get that public IP address. Cool. So let's go to that public IP address and see what happens. Great. OK, still pending. That's fine. Let's do it one more time. There we go. OK, so interesting. It's a little bit different than before. You can see that our front-end prod went to our middleware, then the middleware went to our backend, and our backend went to time.jsontest.com. But we're getting a 404, which is really weird because, I mean, if I go to this website, clearly it works. We were seeing it working all this time before, right? It's working. So why are we getting a 404? And so now we go into the world of Istio. So I actually have Istio already running in this cluster. And what Istio is going to do is it's going to really lock down and help you manage your microservices. So it knows that time.jsontest.com is an external service. And by default, it's going to block all traffic going out of your cluster. And this is really good for security reasons. You don't want your app just talking to random endpoints on the internet, right? You want you as a cluster administrator to be able to lock down and only talk to trusted endpoints. So by default, everything is blocked that's going out of your cluster. So how do you unblock it? Well, in Istio, we have something called egress rules. So it's a pretty simple thing. You can see it's only like a few lines of YAML. And so here, we're going to say, allow traffic to time.jsontest.com on both port 80 for HTTP and 443 for HTTPS. So let's deploy that rule. Cool. And for Istio, we use the Istio control command line tool. It's just like the kube control or kubectl, istioctl. I don't know how to pronounce it. Your guess is as good as mine. But it's very similar to the kube control tool. And so now we've created that. We can go back to our website and hit refresh. And you can see it's all working perfectly fine. So we've kind of whitelisted traffic to time.jsontest.com. Now, you might notice another thing going on. If I hit refresh, just look at this line right here. Sometimes it says canary, and sometimes it says prod, right? And so the reason why this is happening is, by default, Kubernetes will use round-robin load balancing for its services, right? So our middleware service is pointing to any deployment or any pod that has the tag app middleware. But both the canary and the prod versions both have that tag, so Kubernetes will blindly send traffic to both. In fact, if you had 3 versions of canary and only 2 versions of your prod, a disproportionate amount of traffic would go to canary. In fact, 3 to 2, right? Because it's just round-robining. So with Istio, we can actually make traffic go exactly where we want. So let's do that real fast. OK. So what we can do is set something called a route rule. And basically, we can send, whenever the destination is middleware, always send it to prod. And then whenever the destination is front end, send it to prod, and back end, send it to prod, right? Super simple things. But what this happens is, now I hit refresh, it'll always go to our production service. So as an end user, I never have to worry about it. I'll always hit production. I won't hit some like random test build that's running in my cluster, which is really nice. OK. But this is great. This app is like bulletproof, right? It's so simple it never breaks. But in the real world, our code is not perfect. I don't write perfect code. You don't write perfect code. Let's be honest with each other. In the real world, things break all the time. So to simulate that, I have this really cool function called create issues. And what create issues will do is it'll look at a header called fail, and then if that, it'll generally generate a number, and if it's less than that, it'll just return a 500. Yeah. I didn't know how else to make things break on purpose. It's hard to make things break on purpose. So if you've ever, this is a program called Postman, and if you've never used it before, it's awesome. Basically lets you set like headers and JSON and things like that automatically. So let's just do a normal request right now. You can see it works just the same way as doing a request from the web browser. But now we can actually send headers from this tool. And let's set a value of 0.3. So it's a 30% chance of failure. Let's see what happens. Boom, backend failed. Boom, middleware failed. Everything worked. Backend failed again. Everything worked again. Middleware failed. There, everything failed, right? And you might notice that the problem is actually worse than we think. Because in our code, what we're actually doing is we're propagating these headers. These are for tracing. We'll take a look at that in a second. But we're actually forwarding this fail header along each request, right? So it's not just a 30% chance. It's a 30% times 30% times 30% chance of failure, right? And that's where all this cascading failures come into play with microservices, because one failure can just trigger tons of failures downstream. So let's take a look how Istio can help us with this. So let's do our second routing rules. Let's do something called a simple retry policy. So let's have Istio automatically retry the request 3 times before giving up. And again, we don't have to change our code at all, right? Istio is transparently proxying all of these network calls. Proxying is a strong word. Transparently managing all of these network calls. So what happens is our code doesn't have to know at all that Istio is trying it 3 times. It just tries it once. And Istio actually manages all the back off and the retries and all that kind of stuff for you automatically. So you don't have to. So now if we go back to Postman, let's see what happens. Boom, working, working, working. Ooh, still some issues. Working, 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 working. Much better. Obviously, it didn't fix the issue. In fact, if I increase this to something like version 0.5, you can see, it's going to fail a lot more. Or not, it might not fail. It might mask that. OK, you know what? 0.9. All right, see? Failure. And you might notice it's failing a lot at the front, too, right? So let's take a look at 2 things. One, it's able to mask M-A-S-K, your failures, but you don't want it to always do that, right? Just because things are working doesn't mean things are good. You want to be able to detect that you have errors and be able to detect that and fix it. So Istio actually gives you a lot of tooling out of the box to manage your systems. So the first thing I want to show you is something called Service Graph. So because Istio is sitting and intercepting all those network calls, it's actually able to create a full picture of your services for you. So you can see here we have a front end talking to our prod and canary, talking to our back end, just talking to times.jsontest.com. We can also start doing things, automatically start getting metrics from our cluster as well. Wow, that looks way too zoomed in. All right, zoom out a little bit. You can see here, once we started adding those errors, our global success rate just started crashing to the bottom, right? And so Istio will actually automatically find your 500s, your 400s, your volume, your QPS, your latency, all this stuff automatically for you, and start throwing it onto Prometheus and other dashboards so you can start putting them into your systems and start running metrics and understanding what is going on in your services. Right? And I didn't have to write any code for this. Istio gives me all of these metrics out of the box for free. And then finally, we can use something like Zipkin or Jaeger to do tracing. So our stack driver trace, a lot of these tools all work. So let's find some traces. So you can see here, we can see our front end talks to our middleware, talks to our back end. And we can see that obviously the back end takes the longest amount of time because it's talking to our external service, right? But even more interesting than this, you can see here it actually has backend 2x, front-end 2x, and middleware 2x. Yeah, I can't find one. That's OK. Let's see. Look back. 1 hour. Find traces. That's OK. So you can see all the distributed tracing. And to do that, all I had to do was forward those trace headers along. Let's look at that for 1 second. Those trace headers. So as long as I'm forwarding those trace headers, I get distributed tracing for free out of the box. And actually I have another talk where I talk about open census, which can automatically forward these for you as well. So even less work for you as a developer. OK. Now let's do one final thing. So here you can see when I hit refresh, I'm always going to my prod service. But as a tester, I kind of want to actually use a canary service and see what happens in this new path, right? And the really nice thing is we can do in-production testing using Istio. Because when we have thousands of services, it's impossible to launch them all in our local machine and test it that way, right? We want to kind of push our service, like our, you think it's working, so we push it into our production cluster, but we don't want any production traffic hitting it. We just want our test traffic hitting it. So what we're going to do is put up the last and final route rule. And it's going to make a new route called the middleware canary route. And what it's going to look for is a header called xdev_user. And then whenever it sees the value of super secret, it's going to route it to our canary. So all normal traffic will go to our production service, and then the super secret traffic will go to our canary service. Obviously, you'd use something like OAuth or some sort of authentication scheme, not just the word super secret, because, security is important. So let's take a look at that. So make canary. So let's deploy this rule. And so now if we go here, obviously, it'll still go to our production service. But if we go to Postman, and let's remove that fail header, and let's go to xdev_user, super, boom. Nope, can I spell it wrong? I don't know. Let's see what happened. What happens? Oh, it's disabled? Aha, there we go, thank you. All right. There we go, middleware canary, right? So we're able to route to a specific service in the middle of our stack using headers. And that's because we're using header propagation. So even if you had like 2,000 services, and you want to make the middle one, the 900th service, a special thing, by propagating these headers, we can actually use Istio and then route to that one, even if it's in the middle of our stack, right? So not just the front end. We can test anything in the whole stack using Istio and header propagation. Cool. All right, let's switch back to the slides, please. OK, so we did all this stuff. Thank you all so much. If you want to get a deeper dive into Istio, it's basically this talk with a little bit more things. Focused specifically on Istio. You can check out myname.com/Istio101. It'll have a YouTube video. All this code is open source on my GitHub. Again, if you go to that website, Istio101, I have a link to my GitHub repository there. You can check out Google Kubernetes Engine at g.co/gke, istio.io. Follow me on Twitter. If you have any questions, please follow me out the door. I'm going to go staff the office hours right now, so come talk to me there, or talk to me right outside, or find me in the sandbox. I'm happy to answer any questions. I know we went kind of quickly today. But yeah, thank you all so much. Enjoy the rest of your I/O. Enjoy the concert tonight, and I'll see you out there.